Okay, so we're going to go over 2.3, 15, A, B, and D. So it says log base 10 of 40, right? So they're asking for you to see which ones are equivalent to this. And technically there's two ways to do this, okay? One way to do this is expand it. So you would take all your log rules, which I wrote right here, and then use these log rules to expand it out. Or you could take one of these and condense it. Condense just means making it smaller. So like that condensed mushroom soup, it's just the soup without the water, basically, if you think about it. Okay, so here, what we're going to do is I prefer to take this to try to make it look like this. So if you think about this as like, I don't know, if you're building Legos, this is what I want it to look like, and this is what it looks like right now. Or if you are a designer, this is what I want the room to look like, but this is what the room looks like right now. So every single step, my goal is to get closer and closer to here. Now, some of these are not going to be like equivalent to that. Like you can't make that from that kind of thing. So I'm just going to start with this one just because it's the first one. I'm going to scoot it over here so I have more room. So I'm going to basically take this whole thing and I'm going to be a little bit on the lazy side and just snip it so I don't have to type it all again. Okay, so when I have this here, the very first thing that I notice is that all of these logs are the same. Log base 10, log base 10, log base 10, log base 10. That's the first thing. If they don't have the same bases, then it's broken. Like I can't put it together like that. I can't condense it. So the first thing that goes through my mind, I'm like, oh, log base 10x plus log base 10 of 5 plus log base 10 of 8. That's like this guy right here. So when it's adding on this side, inside the log, we're going to multiply them to get the new argument, right? So you just want me to multiply all of these three, Ms. Johnson? Yeah, exactly. Okay, so if I multiply all those three, I get log base 10 of x times 5 times 8, which I think is 40x. So notice here was my first step. My first step is like, oh, look, I can get this to be 1. So here, if I'm comparing something that's like separate logs to one log, single log, then I'm going to go this way. Right? I'm going to go this way. So then it says, if it's adding out here, then inside the argument, you're going to multiply. So these were adding. So I multiplied inside x times 5 times 8. Right? And then I actually multiplied 40x. So this to me, log base 10 of 40x and log base 10 of 40x are exactly the same. So yeah, this works. They're exactly the same. So the only answer here they're looking for is that you can actually show that they're equivalent. Okay. The next one is B. And it says, and I'm just going to write it right here. It says log base 10 of x plus log base 10 of 4 plus 1. Huh. That 1 is very interesting because over here, right? Like if I look at this here, these all had log base 10s. And Ms. Johnson, you told me the very first thing that I should be doing is checking to make sure that all of them have the same base. But Ms. Johnson, this one does not have a log and it doesn't have a base 10. So what am I going to do with this? So right now I'm going to kind of like put this away in my head for just a second because I don't know what to deal with it. I'm pretending I'm you. I actually do know what to do with, just making sure. Okay. So then, so then we're going to, so I'm going to just deal with this part, not this. Okay, I'm going to deal with this part, not this. Give me 1 second. Okay, so then we have, I'm going to condense those two. So again, if it's adding out here, then it's going to be multiplying inside that argument. So log base 10 of x times 4, right? And then I have this plus 1. Again, this plus 1 is kind of bugging me because I'm like, I don't know what to do with you. But just, again, give it a second. Let me actually multiply these and then see if I can get more direction. So then I say, oh, that's just log base 10 of 4x, right? And then I have this plus 1 all the way out there. Okay. So then I'm going to compare, this is where I'm at. This is closer. Do you agree that this is closer to here? This is further away. This got closer, and then I'm closer, and then it looks like I'm going to get to here. So I have log base 10. They have log base 10. I have 4x. They have 40x. I have a +1 and they don't. So the big thing that I'm going to try to do here is try to figure out, well, how come they have 40 x's and I only have 4? And then hopefully some of you are thinking like, oh, we could rewrite this 1 as a log base 10 of something. Oh, you are right. Okay, so over here, I'm going to say 1 equals to log base 10 of what number? Okay. So give me a second. 1 equals to log base 10 of what number? What number? So yeah, so actually it is 10. Very good. So in the chat, my buddies over there were saying, Ms. Johnson, it's 10. So it's log base 10 of 10 equals to 1. Oh yeah, I remember that property. When the base and the argument are the same, then it's just going to be a 1. So exactly. So instead of writing this 1 here, I'm going to exchange it for log base 10 of 10. And so let's see what I can get with that. So log base 10 of 10. Log base 10 of 10. Okay, so, oh, Ms. Johnson, doesn't this look like this one again? Oh, yeah, it totally does. So if it's adding out here, then it's multiplying in here, okay? So then I would get log base 10 of 4x times 10, which, hey, that's, oops, sorry. Hey, that's 40x. That's 40x. So then I'm really done, and I just write it log base 10 of 40x. Okay, so if you look, the key part here was being irritated that this is a 1 and noticing that you told me, Ms. Johnson, log base 10, this one doesn't have it. But then saying, wait, can I rewrite this? Can I rewrite this 1 as a log base 10? And once you could figure that out, then the rest of this was simple. So the thing that I want you to not shy away from is like this little number right here. Just keep, how do you say this? Keep thinking about how to rewrite these numbers so that they fit more of what you want, right? So this is like, I don't know, if you make soup and you're like, you taste it and you're like, oh, that's not the way I want it to taste. And so you add a little bit of salt. You're just trying to get it to the place where you want it to be, okay? So in this case here, the key was going to be, was really saying, how can I rewrite this? Because I really want a single log. I really want a single log. This is not even a log, Ms. Johnson. So just like you would ask for change, hey, can I have do you have change for a $20 bill? This right here and this right here look different. A 20 and 21s look very different, but the value is still the same. Okay. So I'm going to pause the video really quick so that you guys can try this one. Try D right now. Think about what we talked about and these rules. Okay, so now that you're back, it says d of x is equal to half of log base 10 of 100x minus log base 10 of 2 plus log base 10 of 8. So this one looks confusing to me because it has multiple properties working at the same time. I don't want to get it all crowdy, messy here, so I'm going to copy and paste it as soon as I find my little, here he is. So when I do this problem, I'm constantly thinking of how can I get closer to that log base 10 of 40x, okay? So the first thing that I notice is I notice this half right here as a coefficient. That's the very first thing that I notice, right? So that half right there is very interesting to me. So I look over here and I'm like, oh, I see it. It's right here. So half as a coefficient means an exponent. Okay. So this is where, please pay attention. This is where some students may not understand why this means. Okay. So the very first thing I'm going to do is I'm going to take care of that. So I go log base 10 of 100x to the 1/2. Okay. Now, Ms. Johnson, why did you put it in parentheses up here? So I put it in parentheses up here because this half applies to this whole log argument, right? So it has to go towards the whole thing. Okay. Already right now, I'm going to tell you this is not going to work because over here, I have an X. I have no more X's here, right? And then this X is to the 1/2. So this X isn't to the 1/2. So most likely this is not going to work because of this X to the 1/2. Does that make sense? So I'm just going to continue on just to see what happens. This minus log base 10 of 2, this minus log base 10 of 2 reminds me of this one. So that means they want me to divide. Okay, so I'm just going to copy the rest of it just so. Okay. So this one says, oh, divide by 2. And then this is where people, again, they kind of get a little confused on this part too. Is that plus multiplying, or is that plus dividing because it's behind the minus? Well, look at this guy by itself. Like pretend I put a big old rectangle here. In fact, I'll just like put your finger over this whole thing. Is this log base 10, 8, is it positive or negative? And you're like, oh, it's positive. So positive means that we multiply. Okay. So here, according to this says divide by 2 and multiply by 8. So I'm going to write that out really quick. So I'm going to go log base 10, and I'm going to do this big, gigantic bracket. Okay. Okay. And then I'm going to put a division sign, and you said to put 2 on the bottom. Yep. Put 2 on the bottom. And then I'm going to do this business here with the 100. And technically, if you want to think about this, this is the square root of, so I'm going to do this square root of 100x and keep that x underneath that square root. And then I'm going to multiply it by 8 and make sure that that 8 is very clear. Hey, it's on the outside. It should look very clear. So when Ms. Johnson does things, I make it very clear, like this guy's on the outside, this guy's underneath it, because otherwise it's going to be a little bit confusing. Okay, so still trying to make it look like this thing, still see that x under the square root, and I'm still shaking my head. No, I don't think so. Okay, so let me just simplify more. I see 8 divided by 2, and I see that as 4. Okay, so 8 divided by 2, I'm simplifying that to be 4, right? And then I see the square root of 100 is 10, but I still have that x. So simplifying all that together, this is what I see. I see 10, I see times 4, and I see the square root of x. So still not convinced that I can get this guy over here to 40x. I still am not convinced, right? And I can't. I can't because of this square root. I can't because of this square root. I can't because of this to the half, and I can't because of this half. What they're trying to check with you in terms of this problem is 2 things. Number 1, do you know that this half applies to the whole thing? Okay. Do you know that? And if you didn't know that, then you would fall into the trap of, oh, that's just 10x. 10x times 4, that's 40x. Yeah, it's all good. So this to me is a no. It's a very clear no. And the reason why it's a very clear no is because of that square root of x, because of that square root of x, because of that to the half, and that multiplier or that coefficient of half, because this guy is not the square root of x. Got it? Good job.